All right, packet lesson 3-8, day 2. We are on to page 101. And I'm going to ignore this till last, but this is coming right off the heels of your pre-lesson, and let's just dive right in. All right, now I'm going to purposely pick some that should be fresh on your brain. So I'm going to start with this guy right here. What do we know about this? Well, it says state the domain. In other words, talk about your x's. Well, when we have a fraction, we know you cannot have a 0 in the denominator. So what we're wondering is, where would this happen? Well, that would only happen if x equaled -4, because -4 plus 4 would give us our 0. So if x equals -4 causes the denominator to be 0, then our domain is x cannot equal -4, and that's as easy as it gets. Notice how I didn't talk about the numerator at all, because we can have a 0 in the numerator, but our concern was a 0 in the denominator. Now let's piggyback that one and talk about this one, okay? Well, first of all, look at this. It's x squared. Now think about this. What's a -2 times a -2? Well, that's +4. What's 2 times 2? Well, that's +4. So if I square something, the only thing I'm going to get is a positive number. So this is a strange one. So there's no possible way I could get a 0 down in the denominator. So that means that x, the domain, x can be all real numbers. And if you think about the entire number line, 0 all the way up to positive infinity, 0 all the way down to negative infinity, you can pick anything you want on that entire number line, plug it in there, square it. You will never, ever, 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 ever get a 0 in the denominator. It's just mathematically impossible. All right, in the same sort of lane, you've got this problem now. Again, what do we have? Well, we got our x's in the denominator. So if I said, okay, what would be the problem with that x? Well, what minus 3 would cause this to be, just this little piece would cause this to be 0? That'd be 3. So x cannot equal a 3. But we got to let our minds wander to that x. What plus 7 equals 0? X cannot equal -7. See, this is the easiest way to explain your domain, what x can't be. Okay, now I will just say this. These three problems fit in the same category because they're dealing with fractions. You concentrate on the denominator. You notice that E and F deal with square roots. And at the end of the pre-lesson, we talked about something. This stuff can't be negative. Can't be negative because you can't take the square root of a negative. How do I say this mathematically? Well, that stuff underneath there can be greater than or equal to 0. In other words, you can have the square root of 0, and you can have the square root of anything positive. And that's what we're saying right here. This stuff needs to be greater than or equal to 0. Now you just solve it. So we get 4x is greater than or equal to 2, divide by 4, divide by 4, and I get x is greater than or equal to 1/2. There's my domain. Now, before you leave this problem, think about it. Pick a number greater than or equal to 1/2. That's easy to plug back in. 1. 4 times 1 is 4. 4 minus 2 is a positive 2, and it's mathematically possible. Pick something not greater than 1/2. Okay, 0. 4 times 0 is 0. 0 minus 2 is -2. The square root of -2 is mathematically impossible. That's why this is our domain. All right, just to kind of see the repetition without even thinking about it. You just take that stuff underneath there. I call them roofs. And you set them greater than or equal to 0. That's your way of saying, hey, this stuff can't be negative. Add 2, add 2. 3x is greater than or equal to 2. Divide by 3, divide by 3. X is greater than or equal to 2/3. Pick a number greater than 2/3. All right, 1. 3 times 1 is 3. 3 minus 2 is 1. The square root of 1, I don't care what the answer is. It's just mathematically possible. Pick something not greater than 2/3. Once again, 0. 3 times 0 is 0. 0 minus 2 is -2. The square root of a negative doesn't work. That's why this is your domain. Why did I leave this one for last? Well, because it doesn't really fit into this category, and it doesn't fit into this category where you set them greater than or equal, whoops, over here, set the stuff underneath greater than or equal to 0. This is a unique problem. Think of it this way. It is all over 1. And the only concern I have is if I have an x in the denominator. You see, that's when stuff starts happening because there's a possibility that we can get a 0 in our denominator. But if there is no x in the denominator, we don't have to worry about fractions. We don't have to worry about a 0 in the denominator. And there are no square roots. So the two mathematical no-nos don't even exist. It's impossible to have a mathematical no-no. So we just look at that. We don't see any square roots. We don't see an x in the denominator. That one's so easy that it might be hard. X can be anything, all real numbers. Okay, that's what that represents, all real numbers. Okay. Now, let's move on to this stuff down at the bottom. Now, if we are fortunate enough to be in class for this lesson, I promise you I would turn on my computer on YouTube and I would play a song by Phil Collins, and it's called Inside Out. Now, I would blow you away if I just went on this little solo right now, but I would ask that you YouTube this and play this. He's actually singing about, a lot of people think it's a love song. It's about these math problems right here. Because you got to move inside out. I'll get back to that later. Now, look at this. F of 2. What does that mean? It means let x equal 2 plug into equation defined by f of x. Now, you don't need to write that down every single time. What I'm saying is, a little bit of a Sesame Street moment. Is that an F? No, so don't plug it in there. Is that an F? Yes. So you're going to plug it in right here, okay? Plug what in? 2. All right, I'm going to try to do it over here. So, this is really saying put a 2 in for that x, plug the x in right here and figure out what it is. So it's 2 squared plus 1. 4 plus 1 is 5. Now, that's my answer for this problem. What is this, though, actually? Well, you let x be 2. You plugged it in here. Remember what f of x equals. It equals y. So y equals 5. What did you really find? You found a point with x being 2, because that's what was given, and y is 5. Now, I don't want to do that every single time, but I don't want to lose you either. Now, look at this. Sesame Street. Here's a G. Is that a G? No. Is that a G? Yes. So I need to let x equal -1, plug it right in there. So that's -1 plus 3, which is 2. That's my answer. Here comes Phil Collins now. Got to work inside out. Because, notice what's on the inside. G of 1. So that's like problem number 1. That's just saying put 1 in to the equation defined by G. And that's right here. So I'm going to go 1 plus 3. What does that equal? 4. But wait a minute. I'm going to replace G of 1 with what it equals. So now I'm going to turn this into problem number 2. Now it's f of 4, which means I'm not done yet. So now I got to plug 4 in for x into the equation defined by the letter f, which is right here. So I have to go 4 squared plus 1, which is 16 plus 1, which is 17, and that would be my final answer. All right, what does this mean without so much coloration? That means you got to find f of 1 first. That means find the equation defined by f. It's right there. Put 1 in right here for x. So I get 1 squared plus 1, which is 1 plus 1, which is 2. But now I'm going to take this out and replace it with what it equals. So I get g of 2, which means plug that 2 in right here. So I get 2 plus 3, which is 5. So this whole thing equals 5. Whatever you end up with is the answer to that crazy looking thing. All right, let's go on to here. Start with the inside right there. Plug 0 in for x. Well, 0 plus 3 is just 3. So now I know that I need to find, I take that 3 and I replace g of 0 with it. Now I need to find f of 3. Well, that means 3 squared plus 1. 9 plus 1 is 10. Now they're going to start messing with you and make it a little bit more complicated. Here is the inside, right here, f of negative 2. So I need to put negative 2 into f, so that's negative 2 squared plus 1, which just gives me 4 plus 1, which is 5. But remember, Phil Collins, inside out. So there's a 2 sitting there, so now I'm going to double that, and that gives me 10. So all of this stuff in the middle here equals 10, so I'm going to replace it. And I've got one more problem to figure out. Whoops, I'll put equals 10 in for x into the equation defined by g. There it is, 10 plus 3, and I get 13. See, the math isn't hard, it's just busy work. Now we got a fraction. Do not let this thing throw you for a loop. All you got to do is find g of 3. Well, that just means plug a 3 in there. So I get 3 plus 3, which is 6. So this problem just turned into f of 1/6. Now they're going to test your fraction abilities. This means take the 1/6, find the equation defined by f, it's right there, and plug this in for x. So I'm going to get 1/6 squared plus 1. Well, 1/6 squared is just 1/6 times 1/6 plus 1, which is 1 over 36 plus, now watch this, I can see what's coming. I'm just not going to put a 1 here. I know I need to find common denominators, so I'm transitioning from 1 to 36 over 36, and I get this crazy answer, and that is the answer to that bizarre looking problem. All right. And we've got just a couple minutes left, and here's how we're going to do this. They're just trying to ask you to kind of like be a little, do some investigative work and figure out what in the world could this be. Now, what I'm going to encourage you to do is just kind of think backwards. So, if f of x, what do we know that equals? Y. So here's my y's. That's my domain. Here's my range. So the question is, I need to multiply x by something. I got to multiply this by something and then add 2 to get 4. So I'm going to think in reverse. Let's subtract 2 from here. What is 4 minus 2? That'd be 2. So what do I multiply this by to get 2? Well, 2. So I'm going to take a stab at it. Throw a 2 in there. Let's see if it works for every single one of these. 2 times 1 is 2, plus 2 is 4. 2 times 2 is 4, plus 2 gives me 6. 2 times 3, see I'm going to this one, is 6, plus 2 is 8. See how it's consistent all the way through? So I had to do this problem a little bit in reverse. These are a little bit tricky. You just have to kind of work with it. All right, good luck.